Hello everyone, my name is Kenneth Ekpetere. I'm a PhD candidate at the University of Kansas with focus in geography. My research areas are in extreme precipitation event and development of models to compute probable maximum precipitation, remote sensing application towards flood mapping. I'm also interested in hydrological modeling of flood events and design storms, development of web application for data access. I'm using IMUG precipitation datasets. I'm also having area interest in area of drought, fire. I use ArcGIS, Google Earth Engine for the most part to build my application. And we can see some of the applications I've built here. So I'm just going to focus on the IMUG precipitation extractor. So if you load the link URL here, or you take the barcode here, it's gonna take you to the site, to my app repository, right? So we can see the image precision extractor and focus on that. So the image precipitation extractor is not intended to replace the existing data sources of the IMAG GPM. What it does is to allow users to quickly retrieve precipitation estimates, right, across the globe for point or for polygon watersheds. So you can digitize a point or you can draw your polygons. We have good features here, like we have global gauges, we have global watersheds. So you don't need to worry about the boundaries. We also have the country. So if you want to analyze at the country level, you can use a country, or you can also digitize a gauge there. So, or the watershed. But before I proceed, I would like to state clearly here that I want to give shout out to my project advisor, Amita Mehta. She's been instrumental in this work. She's been helpful working with NASA. And also, I want to give a shout out to my academic advisor, Professor Jingong Li, a very good mentor and one who have really channeled my research in this direction, and also my project PI, Jude Casting, a wonderful mentor as well, who have really helped my research in the long run. So we see we have a kind of description of what the IPE does. And also, this is very important here, so users can always learn about the IMARCH dataset. So that we should tell you about the characteristics or the properties of the IMARCH GPM datasets. And also, we can see other sources, how this dataset can be derived. Um, the cool thing about the IMARCH, the precipitation extractor, is that the tool can enable users to uh, get precipitation estimate not just at 30 minutes, but at longer duration for like 1 hour, 2 hour, up to a week. So it slices for you and give you output. And then also you can get those output as CSV, or you can get the image output as a GeoTIFF image raster, right? And also you can see the storm intensities and the storm movements for an study area, and you can calculate anomaly for a period. So I'm going to talk about all those. But before I proceed, I just want to show you real quick when I talked about the global gauges. We have the current USGS gauges just covering only the US. These are the operational USGS gauges, and USGS is a United States Geological Survey. So you can get precipitation at those gauges, and then you can compare with stations. In addition, I've also included the global gauges, and these global gauges were derived from, I want to give them a shout out from the NOAA, National Center for Environmental Information, and these gauges are called the Global Historical Climatology Network. So this is available here and very useful. So we can see these gauges are all over, and then users can as well use those points to get precipitation estimate. I'm just going to focus on Nigeria here to show what we can do, right? Pretty much when we have these global gauges, right, we can pick a point, and then we can find the location. Let's look at Makurdi gauge. Makurdi is in Benue State, Nigeria. So I pick this Makurdi gauge, and then it tries to center it for me. I go back in time and see, yeah. So I have those points, and then it kind of give you the current date of your current dates, and then you can go back in time up to 2000, and then 2000 to date you can get the precipitation there. So I'm just going to leave it the way it is because it's set to almost 1 month, and I'm going to get the 30 minutes precipitation. It tells here that it can give you, you cannot get a raster because it's a point, right? So to export a raster, use a polygon or rectangle AOI type. So we have the precipitation estimate for that Macaulay area, and then we can always use that estimate to compare with station if we want to do assessment or validation at any time. And then we can get them for even longer durations. We can get for 1 hour, and we can get for up to 24 hours. So I'm just going to slice 24-hour out. So what it does, it clears out the previous selections and content and recenter it and try to aggregate the 30 minutes based on 24-hour time step. And then it's going to give you that output. It's going to take a while, so we see those precipitation. So these are kind of accumulated precipitation depth, and then we can use this. We can import this CSV. So when I click here, I have the cool map. I can download as CSV. I can download as PNG or SVG. Usually I go with CSV, and then users can get a CSV, open it, and real quick. I'm just going to do that real quick and see what we have. So I open the first one and to see what we have there. And so yeah, so we have those information are pretty much given. So you can then use them for your work as the case may be, right? All right, so I'm just gonna really quick touch base on this other part I mentioned here. So we also have, so I'll try to clear this. When I refresh the app is going to refresh, clear everything, and then recenter. I want a cool base map, and then I want to show this. We also have the country, right? So the countries, so you can also use the country if you want to do analysis by the country, you can do that. And then we also have the hydroshed, right? So the hydroshed gives you the global watersheds, so the users can quickly use this to digitize the study area. So I'm just again going to go back to somewhere in Abuja. Abuja is in Nigeria, and I'll find a place. So we have this watershed here. So this is pretty important because it's pretty good. So you can just use a polygon, and you can digitize your own watersheds from the hydroshed. Right now we don't have the capability to import watershed, but in the future we hope the API can become available, so users can be able to import their own watersheds and do analysis of their watershed. So when I'm done digitizing, you can make it as cleaner as possible. This can be done. For now, I'm just trying to show you what we can do. And we have those watersheds. Then we can always turn off the hydroshed because we don't need it anymore. And then this is a watershed, and I can then get the precipitation. So what it's going to give me this time around is going to be, it's going to try to calculate, so there's a data here now, it's going to try to calculate the weighted precipitation depth average across, that's for the image. It's going to be like an average map for the time period. And right now, yeah, so we have that. It's going to try to load, and then we can see what we have there. We can get for longer durations, and you can download the image. Let me give it a second. It's going to come, so we can download the image. We could download portal. It's going to try to load the image, and give it a second. It's going to come up, and when it's done, it's going to give you a JOTIF. We can also load the global one, so we can load the global, and then let me see, have a global perspective of precipitation of entire periods. Let's see what it gives. All right, so then we have this image. So we usually users can go in 30 minutes, and what they need to do is to let's see, show in folder, and refresh this. Yeah, so you just need to go in here and then extract it, and then extract files. We extract the files, we have it, we have the image. So what you need to do is to, you have to load it on GIS environment, then you can have the image for your analysis. So pretty much trying to load. One cool thing also I want to show you guys is we have here, you can go back in time and you can do analysis. But before then, also look at this, the storm part. So pretty much we can do more here, and I'm just gonna clear this out and show you. So I pick the rectangle. I want to see the storm movement right around the tropical area, and pretty much I want to see the storm passing in the past 1 month, and we can see that. It's going to try to compute other frames and show us the storm movement. So here we see the storm precipitation pattern and movement and where they are concentrated at the tropical, right? And then we can see the kind of concentrated areas there. It's very important. And one more thing, we can calculate anomalies, right? So we can also see the anomalies, and pretty much, for example, I have this already shown up, so we can just withdraw the study area, say example around this Nigeria, and what we see when we select the anomaly, this is for between 1st January to the end of December 2011, and I can see for the year we can get the anomaly, and we can see how the individual month deviates from the mean of the monthly precipitation estimates. Thank you.